In my last video, my video got stopped somehow, so I'm starting again. So, this here we have to write the net list. We have to name net list here. So this will be uart underscore tx, and this will be our uart underscore rx. Okay. Okay, and now we'll add this global port. So this will be 1 second. We'll just copy, and then add here in the global level, and this is rx. So this will be output. It will be output to the MCU. Edit again, and it will be right. Okay, so this will be rx, and now again copy it and then paste, then copy, then paste, and this will be input, and it will be okay, right. So from MCU, TX data will come here, and then it will be RX of this RS232, and then the port will send data to TX, then it will receive here, and then after receiving it will out to MCU. Okay, so TX in, then TX out, it will be RX, then TX in, it will be RX, and RX to the controller. Okay, all right. And now we have made some bridge connection here. So when this is DNP, this is DNP, these two register will make the connection. And if you want to change the interchange it, if during bring up, if something will happen, we have to interchange the TX and RX, then we can simply make this as a DNP, and then RX will act as a TX, and TX will become RX. Okay, so and now we'll mark this don't connect. Okay, these are the not connection marking. You can mark it by pressing Q button of your keyboard, and then what is left, this we have to delete here, and then we have to go to the MCU again, power input. So this will be our 3 volt. Okay, apart from the this max 232 IC, so we have checked here, and this max 232 IC has a voltage range of the 5 volt. So when I search this device, it has a voltage range of the 4.5 to 5.5. so we need a level translator. So we are going to use this device, TXS0102 DCTR. You can download the device from Snap EDA. Again, we have to add our symbol editor and the footprint editor. We'll download the file. Okay, and then we will download the step file. Now we are going to import the file. Okay, first I have to select this one, and then import symbol. So this is the device here, and then import the file, save it. So this is the file, and this is our reference schematic, schematic symbol. So 3 and 7, so 3 will be right here and 7 will be here, and then 5 4 and 8 1. Okay, so 5 4 and then 8 1 will be here, 8 1 will be here, and then 5 4 A1 A2 and 1 8 1 B1 B2. Okay, and then 6 OE and 2 ground. 6 is OE and 2 is our ground. Okay, rotate it, and then I'll place right here, and this is our device. And okay, so 3 7 5 4, okay, A1 A2 and B1 B2 8 1, and 2 is our ground and 6 is our enable. Okay, so we'll save it and we'll go to symbol properties again, and then manufacturer name, manufacturer part number, supplier and supplier part number, copy Texas Instrument, and then part number copy, and then supplier and supplier part number. Supplier part number is here, and this will be our digi key, and dataset link. We can directly copy this digi key link here, and the value disable, manufacturer name disable, supplier details disable. Now copy this description, then okay, copy this name here, and okay, all right. And now what is left is we have to import footprint. So import footprint and select footprint, and then save it, copy it, and then okay, and then file, footprint properties, then again step file. Okay, and now this will be -90, and this is done. Okay, now we'll add the device here. We'll go to the symbol properties, and then we'll go to this footprint, and we'll add the footprint here. This is added, and now okay, and then okay, so it is done. And now we are going to use this device in our schematic. So we'll select the device here, integrated circuit. So this is our okay, this is a device. Okay, delete it, then delete it, okay, and now Okay, okay, and now we have to place our device here. Okay, so I have made a connection here. So in this we can see this VCCA has voltage range which is lower than VCCB, and this is bidirectional channel it has. So VCCB I have connected to 5 volt, and this VCCA I will connect to 3 volt. So I will add power lines here. So the power I want to add is 3 volt, so this will be our 3 volt. And now again I have to add resistor again, so I'll add resistor. Okay, I need 10k. Okay, and resistor 10k added, and now I have to add 15k. Okay, so I will copy it and I'll change the value to 15k. Okay, so this will be our 15k. Okay, and now as per this reference schematic, and this enable is connected to VCCA. So okay, so I'll make this ground connection, and then I'll add this tape entry here. Okay, okay, and then I have to add this 5 volt, and now what I need is 100 NF right here, 100 NF right here, and then I also need 1 UF capacitor, okay, and now copy this ground symbol, and then okay, then this will be for 5 volt filter and this for 3 volt filter. Okay, so this is done. Alright, so MCU will send data here to TX, and TX will come here, and then to T2 out it will be RX for the this DV9 connector, and then when TX will come from computer or other peripheral from external world, then TX will come here, and then it will become RX for MCU, so it will reach to the RX, and then it will be RX out, and then it will be RX out from this level translator. So up to here the voltage will be 5 volt, and from here the voltage will be 3 volt. Okay, and this is done, and now we are going to add headline for this schematic. So I'll just copy this LoRa module text, and then I'll write here to RS232, and this will be for RS232 transceiver. Okay, and now this one just place here, and then I'll go to page setting, and then this will be gateway revision A, and then RS232 transceiver, and then 002, 1302 and 2022. Okay, so data I have added. So this is it. So we have completed our RS232 transceiver, and now what left is power side. So we'll draw the schematic for this input power section. So see you in my next video. Bye.